Hello students, today we're going to take a look at 9.4, solving quadratic equations by graphing. For this, remember we are still graphing parabolas, so all of our original information stands, and that is, our standard form is y equals ax squared plus bx plus c. So going to graph this problem, we have to get it into our original form, or our standard form for graphing. So with that, I'm going to minus 6 from both sides to rewrite the equation as x squared plus x minus 6 equaling 0. From here, I'm going to write the related function form, which would be x squared plus x minus 6 equaling y. With this, we should be able to graph. First thing that we're going to do is we're going to find our vertex. And remember from last section, we find our vertex by finding the value, the x-coordinate first, which would be negative b over 2a. So in this case, it would be negative 1 over 2 times 1. So with my x-coordinate found, I also have the axis of symmetry, which would be right through this vertical line and negative 1/2. And we will use that axis of symmetry to our advantage to find one of our answers. Now to find our y-coordinate of the vertex, given that our x-coordinate would be negative 1/2, I simply plug in negative 1/2 into our equation. So negative 1/2 squared plus negative 1/2 minus 6 will equal our y-coordinate. With this, I see that I would have 1/4 plus a negative 2/4 minus 24/4. And that will give us a total of negative 25/4. So now that I have my y-coordinate of my vertex, I know where that coordinate would roughly be, and that's basically 6 1/4, so my vertex is right there. I also know, since that my a in my original problem is positive, I know this graph will turn up. Now all we're going to do is we're going to slowly step one direction, okay, from this vertical blue line. So I'm going to start stepping to the right in that direction for my values of x. If I put 0 in for x, I see that my y would be negative 6. Well, this is not what our answer is. Remember, we want our answer to reflect a solution for these two equations up here. Basically, we want to find the values of x that would make y 0. So right now we see that y is negative 6. We must continue. My next choice would be 1. If I choose 1 and plug that into my formula, I would get negative 4. So here I'm getting closer, but I still have not found the solution. If I plug 2 in, when you plug 2 into your equation of y equals x squared plus x minus 6, your result will be 0. And that is our winner. So right there we have found one of our answers. And with that, I can use my axis of symmetry to figure out how many spaces I need to step to this side. So I have to go 1/2 and then 1, 2 full units. So that puts us right there for our other answer. So I know that if I would plug in negative 3, I would also get 0. So your graph looks like this, going up on this side, going up on this side, and with these special points called the roots, you have your answers. So the answer for these equations is that x would equal 2 or negative 3. Again, as a check, what you could do is you could open up your grapher, type in the equation that you are asked to solve, which in this case was x squared plus x minus 6. Oops, I forgot to get out of the denominator. Plus x minus 6. Hit return to see what your graph looks like. And just by taking a look at this, you can see that your points right there, it's kind of hard to get it exact, but you can see your points are close to -3, and then over here you can see your point at 2 crossing your x-axis. So we are looking for those points and we have found them, and again, those are called the roots. Alright, let's try to look at one more of these problems before you head out. Okay, here we go. Problem number 2. Well, problem number 2, I really wouldn't suggest solving by graphing, but we're going to show you how you can do both methods. The first method that you would do, and more than likely, is solve algebraically. To solve this algebraically, you simply divide by 3 on both sides to get x squared equaling 9. And then from there, when you take the square root, you can see that x would equal plus or minus 3. Now, solving graphically changes this a little bit. Again, I want to get it in the form of y equals ax squared plus bx plus c. So in this case, I would rewrite the problem as 3x squared minus 27 equaling 0. Related function form, where I'm replacing y, or 0 with y, would be 3x squared. And if I want to know what the bx piece would be, if it's missing, that would simply be plus 0x plus. Okay, with this done, and plus our c, remember, would be negative 27. So with this done, what I need to do is figure out what my vertex would be. So again, I find the x-coordinate by going negative b over 2a, and in this case it would be 0 over 2 times 3, but it really doesn't matter what the denominator is as long as it's a non-zero. I can see that this would be 0. So with my x being 0, I simply plug it into my equation to figure out that my y is going to equal negative 27. With this, I'll probably count by 3's on my graph, which would put us right there. Again, since we've done this algebraically, I'm not going to spend too much time, but I'm going to try the number 3. And if I try the number 3 into the equation, I see that my y would be 0. Remember, counting by 3's, so 3, 0 would be located right there. And then, of course, using my axis of symmetry, which is the y-axis, I can see that my other answer would be right there, and that would be negative 3, 0. So my graph, looking like this, results in 2 answers, with x being equal to plus or minus 3. And again, remember, those are called your roots. Or basically, where the graph is crossing your x-axis. Students, again, remember, have these problems down in your notes and come to class with a couple questions so we can get through this material. Thank you.